Good morning all. My topic is problem solving using algorithm and flowcharts in computers. So before solving any problem, we should understand the problem first. We have to analyze the problem first. Okay. So before applying any technique to a problem, we should understand the problem. That is, problem analysis is the very important method in problem solving. Okay, once we are analyzing the problem, we should come to know the objective of the problem, we should come to know the aim of the problem, so that we may understand the inputs which are needed for the problem and what output it needed from the inputs. Okay, what are the outputs we have to generate from the given inputs. Okay, so that procedure of converting that input into the outputs, we are calling it as algorithm. That is process steps, the logical sequence of steps. So sometimes the problem may be complex in nature. So such cases, the complex problem you have to decompose into different modules, and we should find the solution of individual modules, and we have to integrate all the modules. Okay. So always we have to draw a structure chart that gives the hierarchy of the complex problem. Okay. So all the problems whatever we are discussing here, it is formal problems. That means formal problems only we can solve through machines, computers, because whenever you want to solve a problem, means we need a clear-cut, concise steps. We need a clarity in steps. Okay. In informal problems, there may not be any clear-cut steps to get the solution of the problem. Such problems we cannot solve. So here we are only discussing formal problems. Okay. So in software, before going to the algorithm, we should know SRS, software requirement specification. Software requirement specification means once we are analyzing the problem, we will come to know the objective of the problem, the aim of the problem. From the aim, we will come to know the inputs which are needed for the problem and what output it should generate for the given problem. So between input to output lies algorithm, that is process logic. So algorithm is nothing but a well-defined sequence of logical steps in order to reach the solution of a problem. Okay, so it should be always independent of the programming language. It should be finite. That is important. And always algorithm always has an initial and a terminal point. It should start from a particular point and it should end also. But whenever you are writing algorithm, it should start from the initial point and it should reach to the infinite. It should reach the end point. It should not hang in between. Okay, so always while designing algorithm, we have to think of two things. One is time complexity and space complexity. Time complexity means an algorithm is efficient means it may take less time. It means it is always inversely proportional to the clock speed of the processor. Okay, space complexity means it takes less memory. And less memory in the sense it is taking less number of variables. Okay. So always an efficient algorithm will meet the worst cases. Okay, now there are three cases we can see it in algorithm: best case, average case, worst case. So always an algorithm is efficient means it is meeting the data with worst case. So it will give the results in all situations. So there are some examples we can see here for algorithm. For example, we want to put a book into the box. So what is algorithm for that? So start, pick the box, third step, put the book into the box, close the box, end. That is, all the steps are mandatory. This type of instructions we are calling it as sequence. Second example, finding the sum of two numbers. These are also an example of sequence. Start, step 2 is read n1 and n2, then sum is equal to n1 plus n2, print sum, end. So all the steps are executing one after another from step 1 to step 5. So sequence. So example 3, it comes under selection statements, selection algorithm, because all the instructions are not executing. Based on the condition, based on the validation, some steps are executing, some steps are not executing. You can see validity of the voters, validating the eligibility of a voter. Okay, we are reading the age, then we are checking the voter's age is above 18 means we are saying step 4. Step 4 means voter is eligible for voting. Then step 6, that means step 5 is not executing. So this line is emitting. So whatever lines between 4 and 6, it will not work. Okay, Suppose the voter's age is lesser than 18 means only it will go to step, where it will go? It will go to step 5. It will go to step 5. Step 5 means voter is not eligible for voting. So automatically it will go to step 6. So this is selection statement. Next one is iterative statements, looping statements. You can see the finding the sum of any four numbers. Just see start is equal initially start, sum is equal to 0, count is equal to 0, read n. Read n means first number. Then that number we are adding with the sum. Okay. Then counter initially it was 0. We have taken read the first number. So count is equal to count plus 1 means count is 1. Again count is lesser than 4 means whether we have read all the numbers. No, we only read first number, only one number. So again we are going to the second read. Okay. So second number we are reading. Again that number adding with the sum. The counter is incrementing by 1. That means counter is 2. Again it is checking whether number is reached 4. No. Again it is reading the third number. Again it is summing with the previous value. Counter is incrementing. Third value is read. Then again not reached. So again reading the fourth number. So when after completing the fourth, again it is printing. It is false. False means it will go to step 8. Step 8 means summing the print sum. So that means this group of statements, that means statements from step 4 to step 7 is executing continuously 4 times. That is looping operations. So always we can see in an algorithm there are three statements we can see. Sequence means all instructions are mandatory. Selection means not all instructions are mandatory. Some are mandatory. Selection statement based on the condition, some are executing, some are not executing. Iteration means a group of statements are working a certain number of times until the conditions meet. As long as the condition is true, it will work. That is iteration. Next is flowchart. Flowchart means nothing but the pictorial representation of algorithm. We know always picture is more effective than words. So when an algorithm is representing in pictorial format means graphical format, everybody can understand easily without reading the lines. Okay, so this is flowchart. So these are the different tools, symbols we are using in flowchart. Start and stop is representing through oval shape, that is oval. Process is rectangle. Okay, instruction or command. Decision box means diamond. So here we are putting the conditions. It may be always decision box always have one entry point and 2 exit points. We will come to know when we are drawing the flowchart. Okay, input output symbol is representing through parallelogram. Okay, connector. So when your problem is not able to represent in one page means it will go to the next page. So between pages you can connect with the page connector. Okay, you have to label it and you have to continue. Okay, same label you have to use it in the next page. This is between the flow symbols we have to connect with the help of flow lines. It may be left, right, up, down. Okay. Now we can see some examples of flowchart. How to find the sum of two numbers. Okay. See start, reading the first two numbers, rectangle, some num1 and num2 adding and some storing and some variable, printing, end. Next is finding the biggest among three numbers. We start reading the three numbers. If A is greater than B, again what we are doing, S means A is greater than C, again checking. S means A is highest. A is false means C is highest. The same way A is greater than B, false means B have to check. B is greater than C. Okay, so B greater means yes, B is biggest. Otherwise C is biggest. So both the cases C you can see here. So always we can see in a decision box one entry point and 2 exit points. Yeah, 2 exit point means yes or no. So this is an example of selection statements, because when this on this top condition is true means left part is not executed, the right only will execute. When false means right part won't execute, left will execute. That is selection statements. Next is flowchart for finding the factorial of an integer. What you meant by factorial, 5 factorial means 1 into 2 into 3 into 4 into 5. Suppose you want to find the factorial of n. N means first the variable I has to set as 1. Factorial is initially set as 1. So we are checking I less than or equal to n. Yes. Suppose I want to find the factorial of 3. So I is 1, n is 3. So it is 2. So I is equal to I plus 1 means I is 2. So fact into I means 1 into 2. So it is again coming here. So I lesser than n, yes. 2 lesser than 3, yes. Again I is 3. So 2 into 3, 6. Yes. Then I lesser than or equal to, yes. 3 lesser than or equal to 3, false. So it will print the factorial of 3. So 6. So afterwards it is coming to the end point. Always algorithm, flowchart or algorithm will come from start point to the end point. That is important. We are getting the solutions. So before the terminal point, we can see the solutions. Thank you very much.